Hi to all, how's it going? So after my last two tutorials about the in-context modeling workflow, I got some feedback from users saying that the tutorials were a bit hard to follow. And indeed, this workflow is a bit complex. So I decided to do a compressed and simplified version of the two tutorials. But I highly recommend that after you watch this one, you go and watch the other two that you will find links in the video description, because there is a lot more nuance and complexity to this workflow than what you will see in this video. So the goal for our little project here is to create ourselves 3 components, assemble them into some sort of a assembly, then create a connecting plate that will bolt them all together, referencing after the previously mentioned assembly, and then create a final product that will be a assembly of all 4 components. So let's start our project from scratch. I will create a new file and I will save it as component 1. In this file, moving to the part design workbench, I will create a new body and rename it as, select it and rename it as component 1. Inside this component 1 body, I will create a new sketch on the XZ plane. Okay, I will create a construction rectangle. You can choose to create a center rectangle. This one I want it to be so L on the keyboard 100 millimeters. This one I want it to be 80 millimeters in height, so I on the keyboard 80 millimeters. Now let's switch to regular geometry, choose the polyline, and I will make my regular geometry. Right click to dismiss the tool. Switch to construction geometry, again the polyline. Right click to dismiss the tool. I want this vertex here, and this one here to be symmetric. So I will press S on the keyboard. I want these 3 edges here to be equal. So E on the keyboard for a equality constraint. Switch to normal regular geometry. I will draw 2 circles. Select them, press E on the keyboard for a equality constraint, R on the keyboard by selecting one of the circles, and I will give it a 10 millimeters, so 10 millimeters diameter. And we have a fully constrained sketch. So let's close our sketch. I will pad it, symmetric to plane for 100 millimeters. Okay, select our component 1, Ctrl D on the keyboard, and I will give it a color to distinguish it in the assembly. To have a prettier component, I will switch to selection on top, select these edges here, and give them a 2 millimeters chamfer. Switch to shadow mode, and this way we have modeled our first component. Now, I will create another file. I will save it as component number 2, and we will create a new body. Inside this body I will create a new sketch. I will map it on the XZ plane. Okay, switch to construction geometry, center the rectangle. I will basically do the same component as before. We have a fully constrained sketch. I will pad it 100 millimeters and symmetric to plane. Hit OK. Let's switch to shadow mode. Select your body, rename it as component number 2. Ctrl D on the keyboard, and I will give it a color to distinguish it later when we will do our assembly. I will select these edges here and chamfer them for 2 millimeters. And we have constructed our second component. Now, let's save it. I will create a new file. I will rename it, I will save it as component number 3. I will create a body, rename it as component number 3. I will create a sketch on the XZ plane. Okay. I will do a centered rectangle. Select this edge here, L for a horizontal constraint of 100 millimeters and I for a vertical constraint of 80 millimeters. Now I will switch to construction geometry, choose the polyline. I will do 3 edges here. Now, right click to dismiss the tool, select these 2 edges and press T on the keyboard for a tangency constraint. Again, this edge here and this edge here, T on the keyboard for a tangency constraint. I will switch to regular geometry. Let's create 2 circles. Right click to dismiss the tool, select the 2 circles, E on the keyboard for a equality constraint, and select one of the circles, R on the keyboard for a radius of 10 millimeters. We are not fully constrained yet, so we need to make these 3 edges equal by pressing E on the keyboard. So close our sketch. Now I will pad my sketch for 100 millimeters and symmetric to plane. Okay. We have our third component selected. Ctrl D on the keyboard. I will give it a bluish color here. Let's close this dialog. Select these 4 edges here and let's do a 2 millimeters chamfer. Okay. Switch to shadow mode. Now, in the context of our project, we have created our 3 components. Now I would like to assemble them, and after that create a plate that will reference the geometry of the assembled components. Keep in mind that one of the goals of our project here is to have components modeled into separate files that will later be available to be assembled into a top-level assembly. So I will proceed by creating a new file. I will save this file as Free Components Assembly. And if you go to Windows Tile, you can see how we want to bring all the 3 components here into our Free Components Assembly file. We have 3 components into 3 separate saved files. I will maximize the window of my Free Components Assembly file here. And in FreeCAD, the most efficient way of bringing in geometry from external files is by creating links. A link in FreeCAD is a particular type of object that shares visual and geometry data with its linked origin, and you can basically see this as a clone, but has the advantage of having its own position, scale and material override. So with the theory out of the way, let's start by creating links of our 3 components in order to create our assembly. We need to bring into our assembly file our component 1, 2 and 3. So I will go to my component 1 file. I will select the geometry that I'm interested in, go to my components assembly file, and by pressing this icon here, I will create a link. This will bring into my components assembly file the geometry of my first component from the component 1 file. I will do the same for the component 2, so I will select in the tree view the geometry that I want to link, switch to the components assembly file, hit this button to make a link. Choose the component 3 file, select the geometry that you are interested in, switch to the Free Components Assembly file and create another link. So, as we've previously said, the linked objects can have a positioning of its own. So if I select the second component and choose the transform option in the right click menu, I can move my component in a different position. I can choose my component 3 transform and I can move it into a different Now I will switch to shadow view, and our goal is to assemble these 3 components into some sort of a assembly. So I will switch to the assembly free workbench, And if I go to View, Toggle Axis Cross, move to Front View, I can see that the first component was imported in the same placement as it was modeled. But remember that links can have a positioning of its own. What I want to do is to have the bottom of this component at the origin of our file. So I will select my component. I know that it is 60 millimeters in height, so I will move it for 30 millimeters in the Z direction, and this will place it essentially. So it is not 60 millimeters in height, it is 80 millimeters in height. So I need to move it 40 millimeters in the Z direction to have the bottom of it aligned with the origin of our file. As we've said, the goal is to assemble these three components into some sort of a assembly. So I will create a new assembly. Let's expand the tree of the assembly. I will select my three components, the links of the three components, and I will drag them in the parts tree branch of the assembly. To have a functional assembly, the first element that we need to have is to have a locked constraint set on one of the faces of one of the components. A good candidate for this would be this face on the first component. I will select it and apply a locked constraint. As you can see, we have a new branch tree called constraints with a locked constraint, and if we expand it, we see that we have one element that represents the face that we've just selected. Now, let's select our third component. Press AA on your keyboard. I will move it slightly out of the way. Escape to dismiss the tool. Select the second component, AA on the keyboard, and I will roughly place it the way I want it to be assembled, in order to have to help the solver solve the assembly. So I want to match this face here and this face here. I will select them and I will apply a plane coincident constraint. As you can see, the faces were matched at a slightly off angle. So to remedy to this, we can select this face here and this face here and apply a same orientation constraint. Because the component 1 has the locked constraint attached to it, it will stay in place, and the other component will rotate to match the orientation of the face on the first component. Now, the next step would be to match this face here and this face here, and because this is a easy one, I will select them and apply a attachment constraint, but we've got an error and we can remedy to this by, let's Ctrl Z our last attachment. Let's refresh our document. I will select my component number 3, AA on the keyboard. Let's help the solver a little bit. I will get the component a little bit closer to its final location. Select this face here and this face here, and I will try to apply the attachment constraint again. With this, we have basically completed our assembly. But if I look from the front, I can see that I have a slight error. We have matched the two faces on component 1 and component 2, but there is something off because the two faces are not perfectly identical. And with this occasion, you will see how links work. If we examine a bit our model here, you can see that this edge here on component number 1 is not chamfered, and this fact throws off our assembly. So I will go into my component 1, I will reselect the chamfer, and I will add this edge here to the list of chamfered edges. Now let's go into our components assembly. Let's refresh the file and quickly solve the assembly. And this way you saw how the link of the component 1 has perfectly matched the modifications made into the external files to the original component 1 geometry. Okay, so we have created a assembly of our three components. What I want to create now is a plate that bolts all these three components together. This backplate needs to reference the geometry and position of the holes in this assembly. So to create my backplate, I will create a new file. I will save it as backplate. I will move to the part design workbench. I'll create a new body. Let's rename it as backplate. And this backplate, as we've said, needs to reference the geometry and position of the holes on the three components into our three components assembly. The best way of referencing external geometry when modeling a new component is by using the subshape binder. I will select the geometry that I'm interested in and I will create a subshape binder. I will rename this subshape binder as backplate reference. Now, if I hide for a second my assembly, I can see my backplate reference here, but notice how it was created into the components assembly file. I want to have this reference into my backplate file. So if you remember, the best way of duplicating geometry across files is by creating links. And I will create a link of my backplate reference. I will select my backplate and I want to have this reference duplicated into my backplate file, so I will make a link. Now, if I go to my view toggle axis cross, I can see how the link was created in its original position. Now, let's start creating our backplate geometry. I will select my backplate, I will create a new sketch, I will map it on the XZ plane, OK, and I will start by importing some external geometry. I will import these holes here, right click to dismiss the tool, let's create a regular rectangle. And we have a fully constrained sketch. Let's close it. I will pad it for 10 millimeters, OK. Select the backplate, Ctrl D on the keyboard, and I will give it a different color, OK. And this way we have created the backplate that references the geometry of our components assembly. Let's do a little experiment. So if I go into my component number 3, select the sketch. Let's modify this 80 millimeters dimension, let's make it 100, close the sketch, go into our three components assembly. You can see that the linked objects now mirrors the geometry of the component number 3 file, and I need to go to the assembly 3 workbench and quickly solve the assembly to have the positioning updated accordingly. Now, if I unhide my backplate subshape binder, you can see that it needs to refresh the file, but if you refresh the file, the geometry will be updated accordingly to the component number 3 geometry. Again, this will trickle down into our backplate file. So if we refresh the file, you can see how the backplate reflects the changes made to the component number 3. Okay, so now that we have seen that everything works correctly, the only thing that it is left to do is to create a final product out of our components. Until now we have done what it is called the modeling process. Now we will get to what it is called the final product assembly process. So I will create a new file for my final assembly, and I will rename this, I will save this file as perhaps final product. In this final product, I want to have an assembly between these 3 components and my backplate. So there are basically 2 routes that one can take. We could import the backplate and then the 3 components, or we could reuse this 3 components assembly. So I will select it. I will go to my final product file and I will create a link. There is something that, so let's Ctrl Z, Let's select again my assembly, go to the final product file, let's create a link, and we have it. Now I want in this file to bring in the backplate also, so select the backplate file, select the backplate geometry, because I want to import this backplate geometry into my final product file, and hit the make link button here. I can select my backplate link and transform it, and I want to place one backplate here and one backplate here in the back of our assembly. So if I select my backplate and I go to its properties, I can change the element count to 2. And this way we have 2 backplates. We need to assemble all these components into a main assembly, so I will create a assembly. I will rename this assembly as final product. I will drag my components inside my assembly. If you remember, the first thing that we need to do is to create a locked constraint, and I will use this face here and create a locked constraint. I want to position my backplate here, so I will select this edge here into my locked geometry and this circular edge here on the backplate, and I will use a attachment constraint. This will bring in the plate into its place. Now I will select, if I go into parts, link, the second link of the plate. We can AA on the keyboard to move it roughly into its position, escape. I will select this circular edge here and this circular edge here by pressing Ctrl at the same time, and I will use a attachment constraint. And you can see how we have basically assembled our final product. This final product assembly is what you would call a top-level assembly, because it gathers underneath it all the components that were previously assembled together with the backplate here that references the components in the free components assembly. Now, to show you a really cool trick, you can see how in this top-level assembly you can even modify geometry of external files, because remember, this backplate, for example, is only a link or representation of the geometry present in a external file, and this external file is the backplate here. So in my top-level assembly we have our parts. One of these parts is this link here of the backplate. By double-clicking on it, I activate it and switch to the part design workbench, and now I can even select edges on this geometry here and do a chamfer, a 2mm chamfer, hit OK, and all the linked objects will reflect this change in geometry. If I go to my external file, the backplate file, you can see how the geometry is mirrored. Now, we have called this modeling tutorial a in-context modeling tutorial for a reason. And this is because we have modeled this backplate to have its geometry and its holes reflect the position and the geometry of the holes on the other components. To demonstrate this, if you remember, we have a link of this assembly of components. If I expand it, we have the parts that create this assembly, and we have the component number 3, the blue one. If I select my component number 3 and expand it, we can see that it was constructed by doing a pad using a sketch. If I select this sketch here and I go into the combo view, the model tab, you can see that we have displayed the sketch constraints. These constraints are the same that you've set when you've created the sketch. For example, constraint number 12 should be the height of our cube here, and if I change it to something like 80mm, hit enter, you will see how the whole document recomputes and the position of the holes correctly reflects the changes made to the component number 3. And this is basically what you would call a in-context and parametric modeling workflow. So please, after this, follow the the other two tutorials because they expand quite a bit on this concept. Thank you for staying till the end, and I'll see you in the next one. Thank you.